Okay, chapter 11. This is vectors. I just recorded this, but there was absolutely no sound, so that's why everything has already been written in. Let's go. So, starts off with some of the kind of basic stuff for vectors, which is like combining them one after another. So A to C, you just follow the vectors along, so it would be B plus B, so 2B. If you want to do, say, F to B, so this is F, this is B, go down there, so that's minus B. If you go against a vector, it's just negative. And then against D, so minus D, so minus B minus D. For the parallelogram, if the vector is defined as being at an angle, it makes absolutely no difference. You just follow them along. So if you want to go O to A, it's M plus M. So 2m. If you want to go from A to D, it's this is A, so negative m plus p. It makes no difference whether it's at an angle as to whether it's perpendicular. For a trapezium, there's a few of these questions in here where it mentions a shape. You just need to know a few like properties of shapes. So a trapezium has two parallel sides, so one pair of parallel sides which are not equal in length. If they are equal in length, then it means that the other pair of sides are also parallel, and so therefore it's a parallelogram. This question has D to C being 3A to B, and then splitting it into three parts. So if this is AB, is defined as being the vector A, then this is 3A, and it's split into three parts, so that's 2A and 1A, and then this is B. Once you've got that diagram, it becomes easy. So just I would say if something is written in words, I would draw a picture, because once I've got it, now I can do A to M. I just go A plus B, take away A, so A to M is just B. If you want to do M to B, start here, A, take away B. So the rules, there's not a lot of them, but that just means you need to know them fully, because they are going to come up. So this kind of going against an arrow is minus. So if you're going in the opposite direction, it's minus. Parallel means that they are scalar multiples. Scalar is just a number without a direction. So vector is a number with a direction. Scalar is just the magnitude. So if something is is parallel to a minus 3b, it just means it's a minus 3b times by a number. So to show something is parallel, all you got to do is show that it is parallel, like show that it is a scalar multiple of that. So 2a minus 6b is a minus 3b times 2. That's it times by 4. That is not a scalar multiple of that. This is this one times by minus 1. That's that one times by minus 3. That is not a multiple of that. So if you can write it in this form, where you've got a number and then a minus 3b on the inside with nothing else, then it's parallel. This is a quadrilateral. The first thing I did was to label the A and the 3b and the A plus 2b on the diagram. If there was no diagram, I would draw one and then label it. And then once you've got that, A to B is easy, right? You just follow the arrows that you know. So that's minus A plus 2b. That's why it's 2b. C to B is minus 3b plus A plus 2b, which becomes A minus B. I did that in my head, but you could write that down as well. And then I added them to the diagram so that when it got to later questions, I didn't have to try and find out in my working what the answers were. Put it on the diagram and it's easy to see. Show that AB is parallel to OC. Again, they both only contain B, which means they're parallel. I just showed that by showing that one was a scalar multiple of the other, and therefore they're parallel. These questions with I and J, I is just a unit vector in the x direction, J is a unit vector in the y direction. Sometimes I and j are east and north as well. Just read the question, it will say. And you just treat I and j in the same way that you would treat any unknown in algebra. So if you want to do, I did g, 4b minus a, you do 4 lots of b and then minus a. Put it in brackets so that you don't accidentally add 3j when you should be taking 3j. But then you just treat it like normal. So it's 4 lots of 4i minus 2i is 14i. And 4 lots of negative j minus another 3 is minus 7j. So just treat it like algebra, collect like terms, and you'll be good. The other way of writing them is in column vectors. This is my preference because it doesn't have unnecessary letters. It's just the numbers. But you would just do the top and the bottom separately. It's like they're simultaneous equations. You do half of 9 plus half of 11, add them up. Half of 7 plus half of minus 3, add them up. And keep them separate. Tops and the bottoms are separate, which is why they can be simultaneous equations. You can do that with I and j. You can also do that with like a and b when we do the more complicated questions later. If something is parallel to I plus j, that means that it's, when you add them together, the c plus the lambda d, it's a scalar multiple, so n is just a number of I and j. So I've written these as column vectors because it's how I prefer to do it. And then I can easily see that the top makes one simultaneous equation, so 3 plus lambda equals n. And then the bottom makes the other one, 4 plus minus 2 lambda equals n as well. And then you just solve these simultaneously. They're both equal to n, so I just equated them and solved for lambda. This is a very common trick, especially when we get to the more complicated stuff, solving the top numbers and the bottom numbers simultaneously. You see there's 2 unknowns there, and I can work them both out even though it's just one equation. And it's because in a vector equation the top and the bottom are separate. The reason they use lambda and mu sometimes, like Greek letters, is I think just because they can use C and D as your vectors, like your normal letters, your Roman, are they called Roman alphabet? That would be your normal, that would be your vectors, sorry, and then the Greek letters, lambda, mu, etc. Those will be the numbers. So they're not vectors, they're just scalars. And that way you don't have to worry about which one's a vector and which one's a scalar. To work out the magnitude, firstly, if you want to write magnitude, you use the modulus. On a graph, I like to think of the modulus as being the length or the magnitude of the vector. So 3 squared plus 4 squared square rooted. You just use Pythagoras on all of them. So just square the I part, square the j part, add them together, square root. This is the same. You can add the a and the b together. So 2i plus 3j plus 3i minus 4j, add them together, and then do the modulus, so Pythagoras on them. Work out the length, 5 squared plus minus 1 squared, square rooted. Unit vectors, so it's normally written like this, a with a little hat, is that called a circumflex? Anyway, unit vector is the actual vector divided by the length of the vector. So firstly, work out the length of it by doing Pythagoras. So 4 squared plus 3 squared, square rooted is 5. And then you just divide the vector by 5, both parts. So 4 divided by 5, 0.8. 3 divided by 5, 0.6. The point of a unit vector is that it is 1 long. So it has a length of 1. If I did 0.8 squared plus 0.6 squared square rooted, I'd get 1. It's got the same direction as this, but it's 1 in length. That's a unit vector. Unit means 1, so that should be easy to remember. Finding angles, I would definitely recommend using just a little picture so you can see the right angled triangle in all its glory, and then almost always you're just going to use inverse tan because you're going to get these two numbers. So that's the height, that's the opposite and the adjacent, so tan. yeah, what I was saying is I would write above the x-axis if it's in this section, and then below the x-axis if it's here. So if you look at B, it's 6i minus 8j. Right, that would be, you can still work it out by using 8 and 6. So it's actually the same angle that this would be. But you would write below the x-axis. The one at the bottom there is makes with j, you just work out this angle instead of this angle. Any questions? I mean, this is my personal preference, but I would recommend it for most people. Any questions where it gives you coordinates, but it doesn't give you a picture, I would draw a picture. So here I've just drawn A, B, and C to give me like some visual. And I think that way, if you do like a sanity check on your answer, you can see whether or not you've gone wrong. So position vectors are essentially the vector, the coordinate written as a vector. So it just tells you how to get from the origin to that coordinate. So 3 minus 1, you go 3 across and minus 1. Like, it's exactly the same. You can think of position vectors as basically being coordinates. And once you've got the coordinates, you should be able to work out how to get from one coordinate to another. So to get from A to B, you can either think of that as being minus A plus B, or you can just look at the coordinates. This is 3 minus 1, and this is 4, 5, and it's 1 across. So to get from 3 to 4, add 1, and then to go from minus 1 to 5, add 6. So it's the sanity. It should be you should be able to see it on the diagram that it's 1 across and 6 up. Right? And that's why it's 1, 6. You can just do that as B minus A as well. When you get to three-dimensional vectors in year 13, then you won't be able to draw it, but you'll still be able to use those same skills. To work out lengths of things, you just do Pythagoras. So square these, add them together, square root. Same thing there. To find PQ, you could either draw a picture, right? You've got the two coordinates here. This is 4 minus 3 and 3, 2. Draw a picture, or PQ is Q minus P. And again, these are the lengths of the vectors. So Pythagoras. With questions like this, you're looking for Pythagoras. Again, I'm going to keep saying Pythagoras because geometric problems often come down to Pythagoras. You want to look for Pythagoras. So the angle of A, B, and I, you've got AB. So you can just go across 4, up 3. That angle is going to be inverse tan of 3 over 4. Same for AC, you've got the A and the C, you've got the across and the down, so you can just use inverse tan. Alternatively, especially for the last question, finding the angle ABAC, so this whole angle, I mean, this is your answer to A, this is your answer to B, so you should just add them together. But in some questions you might want to, you might have to use these lengths. So I just worked out those lengths by using Pythagoras, and then you could use the cosine rule. Down here, I would use the cosine rule. So QPR is that angle. Work out this length, work out this length, work out this length. By you've got PQ, so that's just 4 squared plus 1 squared, root 17. You've got PR, 6 squared plus 8 squared, that's 100. And then this length is, you can work it out by PQ plus QR is PR. Right, so P to Q, Q to R is the same as just going P to R. You know PQ, you know PR, so you can work out what QR is, 2 minus 9. So you do 2 squared, 9 squared, root 85. Okay, so Pythagoras comes up over and over again, and now I've got 3 lengths. I want to work out an angle, cosine rule. Find the area of the triangle. I know that angle already because of part A, and I know these 2 lengths, so it's half AB sine C. Yeah, there's some questions about Parallelograms have two pairs of parallel lines, sides, and those sides are the same length as well. So I've done that one already. I don't know if you can see. These were the original points that you got given. That one and that one. I drew a picture, and then this was the first one that I thought it could be. Just if that is 5 across and 1 up, then this is also 5 across and 1 up. Yeah, so you can just do that again and find out the coordinate. And remember, the coordinate and the position vector are basically the same. You just, instead of writing it as a coordinate, write it as a vector, 9/3. The other way of doing it is that this and this could be. I didn't write down what that vector would be, but it would be 4 across and 4 up. So you just go 4 left and 4 down to get to that point. Yeah, the next things, or the last one that I did was this, which is anything with an intersection. These are rarely seen at A level. They're mostly GCSE questions. We don't tend to do them at A level because they haven't changed. But to find or to do anything with an intersection, what my method is I choose like a point to get to P. Describe this as being a fraction of MQ. I've used the fraction as lambda. And then another way of getting from M to P, but using the other diagonal. So you go from M to A and then A to P. So that would be M to A, and then a fraction of A to C. I've called that fraction mu. And then you work out what MQ is. So by using all the stuff that's in the question, work out what A to C is, minus A plus C, and then write an equation for the two different ways of getting from M to P. So either as a fraction of MQ or as a fraction of AC plus MA. Yeah, MA first and then the fraction of AC. Once you've got that and you've written it in terms of A and C, the method is to, especially for these ones that are more marks, you want to split the A parts from the C parts. So the A and the C, it's like having the top and the bottom of a, what's it called? Column vector, the top and the bottom. You can have A and C. You've got two simultaneous equations. One of the A parts, so a quarter times lambda plus a half, sorry, equals a half plus minus mu. And then lambda C, so that's just lambda in mu C. So you literally split the A parts and the C parts into two separate equations. One of those equations is very simple. It's just lambda equals mu. So then I substituted in lambda for mu, found mu, lambda's the same. And then once I know what lambda and mu is, I just go back to my original equation and solve it. This is what I got at the end. That's OP. I think there might be a quicker way of doing that, because the second part, show that P divides AC in the ratio 2 to 3, is basically what I've got here. I got that lambda is 2/5 and that mu is 2/5. So 2/5 means that P is 2/5 of the way along AC. So, you know, by definition, that's 2 to 3. If it's 2/5. But you'll see that question is much more difficult than the exam questions. The exam questions are kind of more simple. I think this might be one of the more difficult ones, but they're all relatively simple. This maybe isn't a basic question because it's an area question, so it's a combination. I would definitely draw a diagram for this, especially after you know all the position vectors. Remember, position vectors are essentially coordinates. Some of them are very easy, so just work out A to B. You've got the position vector of A and the position vector of B, so it's just B minus A, and then that is, use Pythagoras on your answer from A. This question is almost identical. more position vectors, getting a, b. So that's just b minus a. That is the length of the previous one. So use Pythagoras. If you've got a picture, or if it says something about triangle, draw a picture. Straight line means they are parallel and they share a point in common. It's the same sort of stuff again. There's a little bit of ratio involved, so I would draw a diagram, but it's only 2 marks, so don't go crazy. Draw a diagram and then you're looking for what the trick is. Sometimes it's difficult to find, but with more practice you'll get it more quickly. So that is that. If you've got any questions, obviously you can look at the mark schemes that I send out, or look at the back of the book for the textbook answers, or if you can't find it in the textbook or on the mark scheme, ask me in our session tomorrow. Great.